Rashmi, I've started the recording, so I think best of luck to you and Rita Brata. I think you guys are good to go. So we'll see.
Okay. Thank you, Kunal. Good afternoon, everyone. So, welcome everyone to the session. So, today we are going to do the session on UiPath Maestro handling. That would be the first part of the session. And in the second part of the session, we are going to decode the platform units and the UiPath licensing. So, we are part of the UiPath Kolkata community chapter. Rita Brata, would you like to speak more about
Yes,
the community?
sure. Yeah, good afternoon, everyone. Warm welcome to the Kolkata chapter, and it's fantastic to see every one of you. And I just wanted to give a glimpse of our Kolkata chapter, or the Kolkata community. So now we are 1,000+ members strong. And a special thank you to our chapter lead Kunal for his dedication in building and growing such a amazing community. And our mission is to create a space for all the UiPath and automation AI professionals where we continuously learn, connect, and grow together. So we regularly host online knowledge sharing sessions as well as in-person meetups like today's event. So I encourage all of you to stay engaged, join our upcoming sessions, ask questions, and share your own experiences. Okay, so with that, I will also introduce myself before Rashmi. So I am Rita Brata. I have more than a decade of experience in intelligent automation and RPA, and currently I'm working as a pre-sales solution architect at Capgemini. So I'll be doing a session following Rashmi's session. So I hope all of you will wait for that, and I'll hand it over to Rashmi now.
Yeah. Thank you, Rita Brata. So I am Rashmi and I currently work as a senior RPA developer. I have more than 7 years of experience and I currently work in Accenture. So today I will be discussing on the error handling part in the UiPath Maestro. So that will be the first session. So let's begin and try to understand how we can build resilient automation in the Maestro BPM. So, one of the biggest challenges that we face in production automation isn't building the automation. Rather, the challenge that we face is that we need to build an automation that could run reliably on the productions. Even the best designed automation is bound to encounter transient API failures, network interruptions, or expired credentials, or any unexpected error. If each one of these failure would cause the entire process to stop, then there would be a significant business impact. So today we will see how UiPath Maestro help us build resilient BPMN workflows that can recover from failures instead of simply terminating. So when we are talking about UiPath Maestro, we are no longer dealing with a single automation. We are dealing here with multiple components like RPA workflows, API workflows, AI agents, action app, or human in the loop. And these all components are orchestrating together to complete an end-to-end business process. Now, each of these components might have their own error handling mechanism. For example, an RPA workflow might be using a try-catch block inside its processes to handle certain kinds of errors. Or the API workflows will handle different kind of API responses. But when these all components are working together in a long running workflows, then individual level error handling wouldn't be enough. So let's try to understand this with the help of an example. So imagine that there is a long running process that have multiple stages and the process was able to complete till fifth step. But at the sixth step, there was some downtime in some application and the process has stopped. Now, because of this failure, our entire process comes to an halt. And this leave us with an incomplete transaction. So instead, we want the process to recover from that stage. So to recover from that stage, we need certain kind of mechanism that would help us to continue the flow even when there is any exception. So to understand this better, I would like to give you an example of an reimbursement process. So for an example, there is an reimbursement process for which an employer submits an invoice. So there is a process where we have AI agents that are working to extract invoice details from the submitted invoice. And then we have another workflow that is going to collect required approvals so that the reimbursement payment can be made to the employer. Now, when we reach to the stage where we have to make the payment, but due to some transient issue, the API payment could not be done. So now our process will come to an halt. So now what do we do next? Because our entire business process has stopped. Now we have two options, that we either start the process again or we pick up from where it has failed. So if we start the process again, that would not be efficient because we have already performed some actions. If we do that again, that will be the duplication of the efforts. So what instead we could do is that we could introduce a new recovery path or an alternative path in the process when certain exceptions happens. So we will now going to see what are those strategies or what are those alternate paths that we can use when we are designing our BPMN workflow. So we will see what are two different approaches that we can follow. So the first approach is the micro level approach. So in the UiPath Maestro, we are dealing with individual components. So in that individual component, we have one property that help us to do the error handling. So that is the micro level error handling. And the second is at the macro level, where we can utilize the error boundary events that help us to define an alternate path which we can take when there is any exception occurred. So we will look into how these two strategies are different. So the micro level strategy is limited to a single or isolated to a single activity. And we will utilize this property when we are expecting there could be a temporary glitch in the process that would stop our process. And we would utilizing the error boundary events when we have to deal with an, an unexpected exception or some business exceptions. And this help us to create an alternate path where we could even involve a human in the loop to take further actions, or we can create an alternative path. And this, when we are utilizing error boundary event, this we would be able to see in the BPMN canvas, like how the alternate path is going to like continue the flow. So now we will look into firstly the micro level strategy, that would be the retry strategy. So this is limited to a single element. So to implement this, we have one property called the retry error policy in the task that I will show you in the demo. So you will get a better understanding of this. So there are certain properties that we need to configure in order for this retry policy to take action. So we'll try to understand what are the configuration that we have to do in the process. The first thing, if you want an task to retry, we need to enable the retry policy in the task. And secondly, we'll have to define how many times do we need to retry that particular process. Then we also need to define at what interval this retry would happen. And there is also an option where we could tell the process to retry the particular task for all the errors or for the configured errors. And also we are having different strategy of these, how this delay would work. So we have three strategies: static, linear, and exponential. So in the static delay, the delay between the retries is always going to be a constant one. So if we initially have set it as a 5 second, the next retry will also happen after 5 seconds. If we set the strategy as linear, it will keep on increasing every time it goes to retry the process. So initially, if we start with 5 seconds, the next retry will happen after 10 seconds, then 15 seconds, and so on. And if we set the strategy as exponential, our delay keeps on increasing exponentially. So we will try to understand this retry mechanism with help of a demo. So I have created a simple flow to demonstrate how we can utilize this retry property. So I have created a small process that generates an authentication key. Now this process is bound to have some temporary failure. So if there is any temporary failure, it will keep on retrying the process based on the retry strategy that I have configured. And if it is able to process or generate the authentication key successfully, it goes down to the successful path. So let me open the demo. So this is the process that I have created on the BPMN. So here is the first flow that is going to generate an octa token. And using this token, there is another process that is going to update the downstream system. Now, if I look into the property of this particular process, at the bottom, you will see there is an error retry policy. So if we want this particular task to retry for any transient error, we can enable this error retry policy. And here we can configure these properties. That is the max retries. That is the number of times you want this process to retry. So right now I have kept it as 3. Then we need to put the delay. So delay I have kept as 30 seconds. So it depends how much delay you want to keep between each of the retries. Then we have this strategy of how this delay should keep on increasing or whether it should stay static. So we have 3 options: static, linear, and exponential. For now, I have kept it as static. Depending on your use case, you can utilize other 2 strategies as well. And the last, we have retry on errors. So I have kept it that we should retry for all errors. We can also use this property for the configured errors. So it will retry for the configured errors only. So let me run this process and we would see how this retry strategy is utilized. So the process has started to run. The process has failed. So it will now wait for the interval that I defined for 30 seconds, after which it is going to retry this process again. So you can see that the process is trying to retry this particular workflow again and again, as it is continuously throwing an error. So you could see that as per we have defined the errors, the retry strategy, that it should be retried 3 times, and the process when it was running, it was continuously throwing an error, and the BPMN was continuously trying to retry as we have defined the strategy. And after the third attempt, the process was able to successfully generate the token, using which the downstream system was updated and the process was ended gracefully. So we see how we can use this retry policy so that whenever there is any transient error happening for any of the processes, we could utilize this particular property and we could handle such errors, and then our process would not fail immediately. Instead, it would retry, and then our process flow can continue without any hiccups. So now we are going to look into the second type of approach that we could follow in order to handle exceptions. So the second property that we can utilize is error boundary events. So this is a boundary event that we put on tasks that help us to capture any kinds of exception. So there are two things that we could do using this error boundary event. One is that we can catch these errors and we can simply continue with our process, or we could catch the error and define an alternate path. And using this alternate path, we can have a different business flow logic, or we can involve a human in the loop using this alternate path. So we would be seeing how we could utilize this error boundary event. In the second demo, I would show you how I'm using this error boundary event and how you can also utilize this in your workflows so that you can handle the exceptions in a better way. So here again, I have two processes. One process is generating the Okta authentication key, and using that authentication key, we are updating the downstream process. Now, if there is any error in the downstream process, maybe the system is not available, or maybe there is an selector failure, in that case, simply retrying this process would not be enough, because every time we are updating anything in this downstream application, we need a new Okta token. So using this error boundary event, what we are going to do, we are going to define a path that would take the process flow back to the first process so that we can get a newly generated token. And using that token, again, we can try to update our downstream system. So let me take you again to the studio. So here is the process flow that I've created. Here I am having the first process, which is going to generate the Okta token, and the second process is going to update the downstream system. In this downstream system process, I have attached an error boundary event. This helps us to catch the exception, any exception that is thrown from this particular task. So in this error boundary event, we have the option that we need to catch all the exception or any particular exception that we define. So once we have cached the error, I have created an alternate path using which we would again go back to the first process so that a new octa token is created for the downstream system, and then it can again try to update it. Here I have used a gateway. This would help us to check. So here in this, I have kept a loop for retry. So initially I have defined one variable to keep a count of this retry. And here I'm checking whether my retry count is less than 3 or not. So I am only will be retrying it for 3 times. Even if after 3 times it is not able to update the downstream system, it is going to take the alternate path and end the process. And if it was able to process it successfully, it will simply follow the success path. And using this task, I am updating my retry counter variable. So I'll run this process and we will see how this entire workflow is processing. So here we see the downstream system has failed to update. So using this error boundary event, the flow was directed back to the generate octa token process. So it generated the octa token again, and it again tried to update the downstream system. So we were able to create this alternate path using the error boundary event. So here we see, like, even after retrying for 3 times, the downstream system was still not able to update it. So the process has taken this particular part to end the process. So we see how we are able to define an alternate path using the error boundary event. Now we are going to see one more use case to understand how we can use this error boundary event to define different path for different scenarios. So in the third use case, we are going to see that for any unexpected responses, we will be routing the entire process to a different task. And if there is any known error or any known business exception, we are going to route it to a different path. So we are going to take the same use case where we are generating the Okta authentication key. And if there is any failure in this process, so in one process, we are going to define the business exception, and in another, there would be an unexpected failure. So when we have a defined business exception, we are going to create a ServiceNow admin ticket. And in case there is an unexpected response, we are going to email to the support team so they can do a manual intervention and try to resolve the issue. Okay. So this is the third use case where we are having this process to generating the Okta token. So in this particular task, I have set two properties. First is the error retype policy. So if there is any exception, I have just used this retry policy and configured the all the values. And second thing is I am going to throw a business exception using this conditional throw property. So when we are using this conditional throw property, here we could define all the business errors that we want to handle. And based on these business error, we could define an alternative path that should be taken if any of these exceptions occur. So to add this exception over here, we have this option to add the condition. When we click on this, we need to define three things. First is this condition. So whenever this condition is satisfied, this particular exception will be thrown in the process. So using any expression here, we could define when this exception should be activated. The second thing is we need to define the error code. So here I have defined two errors. So we can define multiple errors over here based on our use case. So we need to define the label and the code. And the third is we need to provide these error details. That is optional. So I will be deleting this for now. So this is the first thing that I have defined a business exception. And if this known business exception is thrown by my process, I am going to take the route of this create service now ticket. So for that, I have attached an error boundary event. So in this error boundary event, we have an option that we want to catch all the exception or the exception that I have defined on the task level. So I have defined this business error under task level. So I am selecting this over here. So this exception will be caught by this error boundary event. And for the second error boundary event, I have defined to catch all the exceptions. So if there are any other exceptions that is not defined on the task level will be catched by this error boundary event. And then a notification will be sent to the support team. So utilizing this error boundary events, like we can define an alternative path that would help us to build a path that could be taken whenever there is an exception happening in our processes. So let me run this process and show you how this would take action. So here you are able to see that my Okta token process is failing. So as I have kept the retry policy to retry it for 3 times, it is trying to retry it before taking the next. So here you can see in the process that initially the generate Okta token process was failing. So as I have defined the retry policy, these retry policy, because of which this process was getting retried again and again. So we saw that this process was retried, And after retrying at the end, it has thrown an exception that was caught by this particular error boundary event. So here we can see the error details, that it has failed in the octa generation process, and that same exception that we have defined in the condition was satisfied, and that condition through an business exception was called by this error boundary event. So which activated this particular path, and this particular process to create a service now ticket was executed. So in similar manner, if you are defining any business exceptions in your process and those conditions are getting satisfied, so based on that, the alternative recovery path or the alternative path is taken instead of the another path. So this help us to handle different kind of exception in a better manner, so that our process does not come to an halt whenever there is an exception. So So these were the three use cases. I hope this help you to understand like how we can handle different kind of exceptions and how we can model our entire BPMN workflow to build a more resilient process. So to summarize this, I would say when you should be using the micro level and the macro level properties. So whenever we need to ask ourselves the questions that is this particular task, the RPA workflow, API workflow, or any other task that we are using, is there going to be any technical temporary glitch or any transient failure which could happen? If we see that the answer is yes, then we can take help of this retry policy and we could retry that task the number of times that we want. And in case there is any business exception that we want to handle and we want to direct the flow into another path where we want to maybe involve human in their action, or we want to create any support tickets or notify any business, or altogether we want to follow a different path of processing, we could do that using the error boundary event and the conditional throw property. So that will help us to design the workflow in a more resilient manner. So with that, I would like to end my session, and I would like now to hand over the stage to Ritabrata for continuing with his session.
Thank you, Rashmi. Before I start, I just
Before I
wanted to.
start, I wanted
There's an echo.
I think it has gone Dityabrata now. I think you can.
Yeah. All right. So before I start, I just wanted to check if anyone has any questions pointed to Rashmi so that she can cover, and then I can start my session. It looks like there is a question from Soumyadeep, right? Somadeep. So, Rashmi, would you like to answer it now, or okay? I can see some more questions coming.
Yeah, yeah, I'm looking at the questions.
Sure.
So coming to the bebop questions, like if we are going to set the property for the error boundary event as catch all, so if we are having the catch all and also we are having the defined error, so if the defined error is thrown by the process, it is going to take the path of the defined error. And in case if there is any other exception other than the defined error, it is going to take the path of the catch all error boundary event. So I hope that answers your question. And for Soumyadeep question, I'm not clear with the question. If you can elaborate it more, maybe I'll be able to take it.
I'll try to answer that question for Samadip. So Samadip, I there is no persistence that we maintain within the Maestro for this. It's just like you retrying any activity within a particular workflow. So whenever that particular activity fails, you try to retry it, right? Everything starts fresh. So that's what is going to happen. So we cannot hold like what amount of task has been done and from which percentage it should be starting. That you cannot do it. So on a like I think Rashmi would agree to this, like when you are having something on that canvas, like each task, if you define it in a very modular level, or whatever the products of UiPath that you are using, if you have defined it in a very modular unit level task, then it becomes very easy to do that. But for a long process or a long task, uh, I mean a long RPA workflow, right? Whenever you run a RPA workflow as a job, right, it's internally running your same RPA workflow, or the process that you have created. Now we cannot maintain, we cannot do a persistence there, right? So it can be done like if you have created an alternative mechanism within your RPA workflow itself to retain some data which needs to be looked up and then done it, that can be done. But Mastro is just connecting the dots to the different products to cover your overall RPA workflow. So that's what he's trying to do. But if you have created any persistent mechanism within your workflow, then obviously I think that mechanism will kick off. But if not, then it just retries, or it just makes sure that your exception handling has been done in a proper way. I hope that answers. Okay. Oh,
Okay, great. So I think, I mean, even if you have some questions, you can just post it in the chat. So I'll start my session, and Rashmi can, like, or Kunal can respond in the meantime. That is okay. Is that fine with you, Kunal, and everyone?
I'm good. I'm good, Ritubrata. Like yeah.
Sure. Okay, I think I'm. I hope you're able to see my screen, and you can hear me clearly.
So we can see it.
Yes,
Yes,
Ritik.
yes, yes.
Okay. All right. Good morning, afternoon, and good evening, and thank you for joining. So we are discussing about this topic. Platform unit consumption for developers and architects for the first time, because traditionally licenses, platforms consumption, licenses cost were tracked by primarily by managers and leadership teams. But today, with increasing solution complexity and AI adoption, developers and architects need the same visibility to build cost efficient automations. And if you're in the industry for more than 2 3 years, you will already notice that, right? So don't worry, this isn't going to be a licensing seminar. My goal is to, by the end of this session, you will understand how UiPath platform units work, and more importantly, how your design decision affects consumption. Okay. And I also wanted to give a quick disclaimer. Everything in this presentation that you will see is based on publicly available UiPath documentation, nothing confidential or customer specific. We won't discuss any dollars or rupees today because pricing varies by geography and commercial agreements. We'll only discuss platform units, the common language that every one of us can understand. Okay, let's get started. So, before we actually go into the platform units, I wanted to give you a glimpse of UiPath licensing tiers. So, I mean, the first layer is user licenses that you are able to see: Express, Basic, Plus, and Pro. Think of this as determining what an individual developer or business user can do, right? So, a basic user might have less capabilities than a pro user or a plus user. And the second layer is platform tiers. These are organization level subscriptions like basic, standard, and enterprise. So all of us who are working for an organization are either working on a standard or an enterprise, tier license. Basic is also there, but basic is mostly for individuals or very small businesses uh, that want to automate few task workflows or activities. The important concept is that as you move up the licensing tiers, more capabilities become available, right? So you're not just paying for higher capacity, you're unlocking additional functionality. And then along with additional functionalities, you will have like more features like AI features, enterprise capabilities. These are the extra benefits that you will get as you move to the higher tiers. Okay, why I'm explaining you this is when we actually deep dive into the platform consumption, you will actually refer to this. Okay, so um, now that we understand the licensing tiers, let's look at how consumption is actually measured and built. So historically, and I think some of us already know, if you have already worked in the orchestrator before, UiPath had what's called the flex pricing model. Think of it like carrying multiple wallets, each with a different type of currency, right? So like AI units, robot units, apps units, API calls. So each product you use, there is a consumption, unit for each one of these. So like if you are using agents, then agent units will be consumed. If you are using robots, robot units will be consumed. So while these give organizations granular control, it also made planning more complex. If your automation strategy changed during a year, for example, you decided to build more AI agents instead of using document understanding, you couldn't simply shift your unused capacity from one category to another, right? So that is the reason UiPath has introduced unified pricing or platform units. So to simplify this, unified pricing was introduced, and the idea is very simple. Instead of managing multiple types of units, everything now consumes from a single pool called platform units. Okay, so I'll go to the next one to explain you about what are platform units. Now let's understand the most important concept in today's session. Okay, think of platform units as um, credits in a shared wallet. Okay, so or you can think of it as a metering in your household, right? The electricity. So each and every product that you use in your household, like your washing machine, your AC, or your refrigerator, right? So there would be some units consumed. Similarly, instead of purchasing, like I told you earlier, instead of purchasing separate AI units, robot units, or document understanding units, your organization now buys one pool of platform units. Every eligible cloud service draws from that same pool. Okay. Uh, if I give you an example, if today you run an unattended robot, it consumes platform units. Tomorrow, if you start using AI agents, those also consume platform units. If you process documents with document understanding or invoke some GenAI activities, they again consume platform units. The source of consumption is always the same shared pool that you are seeing, right? The PU. So here you can see all the services or the products that are consumed from the same platform units. So you can see we have document understanding, task mining, communications mining, maestro, process mining, agents, integration activities. All of them are, and also like whatever new products or new features UiPath is bringing on, all of them consume from the same pool, the platform units. Okay, now there is a, you would have a question, how are they actually consumed, right? The answer is very simple. Every UiPath service has its own consumption trigger, which over here you can see, like for document understanding per page processed, right? So if you have a document with 10 pages and you can see the rate is 0.2 platform units per page, then you can actually, then if a 10-page document is processed, then 2 platform units are consumed, right? So I mean, if you can see the other examples as well, if you are using communications mining, consumption is based per message that's uploaded or analyzed, right? So important thing is to understand that it's not every service consumes platform units in the same way. Some are some are based on pages, some on API calls, some on runtime, and others are complete executions. The third column shows the relative platform unit over here. So, I mean, you need to remember that these are standard reference rates, and depending on your agreement with UiPath, the commercial value of those platform units may differ. And that's why we are only discussing platform units today and not the actual pricing. You may also notice that some capabilities consume much faster than others. For example, Maestro execution, right? So one entire Maestro flow that you run consumes 1 platform unit. So one instance of a Maestro run consumes 1 platform unit. And later when I come up with some examples of an entire solution flow, then you will be able to relate. Okay. So traditionally, if you so another very important concept. So traditionally, if you wanted to run unattended automations, you would purchase unattended runtime licenses. This is the model many of us are already familiar with, but with unified pricing or with the introduction of the platform units, instead of purchasing separate unattended runtime licenses, you can simply purchase platform units, and those platform units to run your cloud robot VMs or your serverless robots. The robot execution then consumes platform units from your shared pool. So today, your organization essentially have two choices. Option A, platform units. Option B is unattended runtimes. So it's important to understand that these aren't competing models. They coexist. So an organization can also continue using unattended runtime licenses for some automations while using platform units for cloud robots and newer AI powered workflows. Okay, so even in the beginning when I explained the flex pricing and the unified pricing, which is the platform units and the earlier version, so some of you might have this question in mind, right? That my organization is still using the flex pricing. Like I have separate for AI center, I have AI units. For robots, I have robot units, right? So it can coexist. Like I mean, I will show this to you in a while in the orchestrator, where you can actually see that like probably 1 second. I'll just go there. Okay. Are you able to see my orchestrator screen?
Yes.
Yes.
Great. So if you go here, you can see the licenses, and if you go to the consumables, you can see the platform units, right? And then your organization can have coexistence of other units as well, along with platform units. So specifically for integration, they might be using integration units separately, but the other things they might be using on the platform units. Okay, so but eventually in the future, this will be the only single one, the platform units. So if you see over here, we have document understanding, task mining, AI center, IXP, semantic activities, process mining, autopilot for everyone, serverless. So in my case, this is one of the account which I haven't used, so you cannot see any consumption. But In your case, if you use some of these products or some of these services, you will see where your platform units are getting more consumed, or where you are consuming it less, or where you have not consumed at all. Okay, so you can see that from here. All right, so I'll go back to my slide. And so so far we have talked about platform, what platform units are, how they're consumed, and the different services that use them. Now comes the most important part for the developers, architects, and solution designers, because this is the part that can influence your design. Okay, so every time your automation processes a document, for example, or makes an LLM call, or invokes an AI agent, or runs a process through Maestro, it consumes platform units from the same shared pool. And here's the interesting part: two automations can solve exactly the same business problem but consume very different amounts of platform units. Right. So as architects or developers, we control many of these decisions. Later in another slide, I will show you how it works, like which AI model we choose, how many LLM calls we make, whether we use context grounding efficiently, whether or how we orchestrate the agents, how we design the resiliency. All of these factors are very important, because we should think about platform units the same way we think about the memory or the network bandwidth, etc., during our design. So they are just another architectural resource for you. Okay. Now, I kept this because I get this question a lot. If I keep testing my agent or prompts, am I consuming platform units every time? So this is a very important question, and for us developers and architects, the good news is mostly no. You know, UiPath separates design time from production time, right? On the left, we have design and evaluation time. When you are building an automation in Studio Web or creating an AI agent in Agent Builder, UiPath provides a daily evaluation allowance depending on your license tier. Now, that license tier comes into the picture, right? Which I showed you in the first slide. So when you are building an automation, and when you are testing that automation, you literally consume no units, because you have a daily allowance. You consume, but it is taken from your daily allowance. Okay. Now, like, depending on your license tier, if you are a basic user, or you are a plus user, or you are pro user, you will have more allowances, right? Like, if I cannot give you the exact number, but if, say, for example, I am a plus user, I might have less allowance. I can test it maybe 100 times, but if Kunal is a pro user, he might test it for 1,000 times, right? So those are the differences on the license tiers, whichever user license tier you have. Okay. And another thing is, I mean, this is intentional. UiPath wants the developer to iterate, learn, and improve their solutions from deploying them. However, once your automation moves to production, the story changes. So every production execution, whether it's an AI agent, an LLM call, a document processing workflow, anything, it starts consuming platform units. And this is where architecture becomes important, right? So a workflow that runs once during testing may execute 10,000 or even 100,000 times a month in production. A small inefficiency that seems insignificant during development can become a very major source of consumption. So that is why my recommendation is simple: do your experimentation during your design uh, and development phase, but before it goes to production, you need to understand how much platform unit your solution will consume. Okay, so another important thing is, I mean, I would say one of the biggest levers of architects for the controlling platform unit consumption is the choice of AI model. Okay, so different model have different consumption types. So over here you can see the standard models, basic models, and bring your own models, right? So think about a much so at the top we have the standard models such as GPT-4o, Claude Sonnet, or Gemini Pro. These are excellent for complex reasoning, then business critical decisions, etc. They provide the best quality but also represent the baseline consumption. Correct. Now, think about a much simpler task, um, classifying an email or extracting a purchase order number from a or from a purchase order document, right? These tasks don't need the most powerful model. That's where basic models such as GPT-4 Mini, Gemini Flash, all this comes into the picture. And of course, I mean, if the business problem doesn't require advanced reasoning, you can choose a lighter model, and that can significantly reduce your consumption without affecting the outcome, right? And then UiPath also offers this bring your own model. So, like, if your organization already has an enterprise agreement with, say, Azure OpenAI, Google Vertex, or AWS Bedrock, or another supported provider, right? UiPath allow you to connect those models. Since the model interference happens through your own subscription, UiPath side platform unit consumption is generally lower on those calls. Right? This is a great option for organizations who have already invested some amount in their own models, or they have already taken subscriptions, third party subscription outside of UiPath. And so in that case you can see that the 30%, the platform unit consumption is 30% lower on UiPath side, right? And one more thing I'd like to highlight is something many people overlook is the input token limit. So an LLM call isn't about choosing the model, it's also about the information you send to the model, right? For example, if the model accepts 64,000 input tokens and your prompt contains only 100,000 tokens, UiPath has to split that request into multiple calls. Instead of consuming platform units for one call, you can now consume them for two calls, right? And these limitations are always there, and you have to think about that while you are doing a design. So I would say, like, rather than sending every document, every email, or every piece of history in a single prompt, it's better to retrieve only the relevant informations. You can use like splitter activities, etc., to only select the relevant information. And also you can use context grounding in case of you sending user prompts, or chunking, etc., to only send the relevant context to the LLM models. That way you can save a lot of the platform units, right? So I will go to the next one. So far we have discussed platform units in the theory. Now I will show you a platform unit consumption using a order management workflow. So you can see on the screen here that we have in the order management a document understanding, or IXP, one validation agent, one integration service, human in the loop, and serverless robot. So I'll take you through step by step so that you understand clearly. The first part is the email. So first, just imagine this, that there is an email which contains 3-page purchase order. Okay, UiPath extracts the information from all the 3 pages. Since document understanding is built per page, 3 pages consume 0.60 platform units. So 3 into 0.20. Okay, the first one. Then in the step 2 is my validation agent, right? The agent checks whether all mandatory fields are present, validates the business rules, and identifies if there are any anomalies. During this process, it makes 6 LLM calls, right? And each LLM calls is 0.2 platform unit. So I have consumed 1.20 platform units over here in my second step. Now coming to the third step is the integration service, right? So here the workflow checks the customer details in a Oracle CRM using integration service. So around 40 integration activities are exhausted, right? So I mean, you can see the pricing is 2 platform units per 100 actions in the integration service. So let's say 40 has been exhausted, right? Then in that case, I have consumed 0.80 platform units. Okay. And then now suppose everything matches, and if there is a mismatch, we enter human in the loop. But notice that this is a conditional step. It only executes when there is an exception. Since this example assumes that the order is valid, it isn't triggered, right? The human in the loop isn't triggered, and there is no additional platform unit consumption here. Finally, once everything is validated, I'll come to the step 5, which is the cloud robot updates the SAP with the validated order. The robot runs from approximately 3 minutes, consuming 0.60 platform minutes, right? It's 3 into 0.20. So robots always, the consumption trigger is based on the time. So 3 runtime minutes, in 3 minutes it completes the update in the ERP. So 3 into 0.20 platform minute is 0.60. So if you see the calculation below, 0.60 plus 1.20 plus 0.80, the total comes to 4.20 platform minute per order. So I hope this is clear to you, right? So if your business, say now if you calculate this as at a scale, right? So if your business processes 10,000 orders every month, you are looking at approximately 42,000 platform units per month. Okay, so this is one example of a order management architecture. Now let's check another architecture. This is the similar one. It's not very different, right? You can notice that it has nothing changed from the business perspective, right? The customer still sends an order, we still validate it, we still check the CRM, we still update the SAP, right? The business outcome is still identical. So why does the consumption jump from 4.2 platform units to 16 platform units now? Right? If you see the calculation here, it is 16, right? So I'll also go here step by step. Okay. So first is document understanding. In the previous example, we processed 3 pages, but in this case, we are processing 12 pages. Because in the previous example we might have added a RPA workflow where we were splitting the pages, and we were taking only the 3 of the pages where the actual information of the orders were there, right? But in this case, what we are doing, we are processing the entire document, so we are processing 12 pages. So more pages mean obviously, like, the consumption will increase, right? Then I'll go to the step number 2, right? One thing I actually forgot to tell you. So that is that all of these steps I have gone through, but remember that Maestro also consumes 1 platform unit, because this entire flow runs on Maestro, right? So when I did the calculation over here, I have added 1 platform unit over here for the Maestro 4.20, right? Now going to the second one. So instead of one efficient request, UiPath has to split it into multiple LLM calls for the agent in the second step, right? So what we are doing is, in this architecture, you saw there is a validation agent. In here, what we are doing, what the architecture is built on is, it's not a lightweight validation agent. So it's a multiple chained agents running on a premium model. So here comes the model. So if you notice this, I have used here a basic model, right? But here is a standard model, right? So, and instead of one efficient request, UiPath has split it. So we also perform additional context rounding request over here. So if you see 12 build calls unchunked into 3 versus 64K ceiling. So 64 I told you earlier. So if the token exceeds 64K, then it will be counted as 2, right? And then we have taken 15 deep rack lookups, which is context rounding. So overall, if you do the calculation, it is coming to 5.40 platform units, right? Instead, and in our last design, we were only consuming 1.20 platform units, right? So this is where poor prompt engineering and unnecessary orchestration becomes expensive, right? Then let's see the integration service. Previously, we batched our CRM lookups. If you see here, so we have batched our CRM lookups. Now, what it is doing in the integration service is it is checking per line item, no batching. So earlier we were sending all together, but here it is doing like every order line item triggers its own integration call. So instead of making one efficient request like in the earlier architecture, we are making hundreds of smaller requests. So the business result is exactly the same. You can see in our last, we were consuming 0.8 platform units, but here we are consuming 4.40 platform units. And then finally the robot, right? So previously the SAP update finished in 3 minutes. Now it is taking 9 minutes, right? So that means the consumption has also increased. So 9 minutes means 9 into 0.20 platform units, which is coming to 1.80 platform units, right? And then another very important factor is in this case, suppose because the workflow validation has to reprocess, like in this case it has 2 times, it has processed 2 times in the Maestro. Because of a failure, we are also calculating 2 instances of the Maestro, so 2 platform units. So if I total everything over here, you can see 16 platform units, and in our previous design it was 4.2 platform units. So this is like 3.8 times the consumption, right? So I mean, this is just an example. In real world, you might have seen different scenarios and different architecture designs where you have to calculate this way. You have to understand which way of your design will actually save the platform units to the greater extent. So this is just an example to show you, to make you understand how a little bit tweak in the design can make a lot of more platform unit consumption, right? So we have covered a lot of concepts in the session. So I'd like to leave you with a simple optimization checklist that you can apply in your automation project. First, I would say if you go with this, and later if possible, Kunal will also share with you these slides. So I would say, like, if you take one by one, you should take advantage of Studio Web and Agent Builder to prototype and refine your solution during design time, right? Because design time is free, like we understood. And then second is you need to choose the right model, correct? Don't automatically default the most powerful LLM. I mean, if a lightweight model can classify an email, or just extract a field from from some document very accurately, use it. Save the premium models for tasks that genuinely require advanced reasoning or advanced decision making, etc. Third is, I would say, you need to avoid sending unnecessary information to the model. Retrieve only what's relevant. You can chunk large documents intelligently and use context rounding. Every unnecessary, remember this, every unnecessary LLM call or oversized prompt increases consumption, right? Fourth is, you need to design efficient workflows. So keep your agents focused, batch integration calls wherever possible, avoid unnecessary retries, like you got to know in the previous session from Rashmi. and use Maestro only when your process genuinely needs orchestration. Like I have seen multiple, workflows where Maestro is used forcefully, where actually Maestro is not required as well, right? And then finally, I would say don't wait until the end of the month to look at your platform unit usage. Treat the consumption dashboard just like you do, like I showed you in the orchestrator. If you get a chance, or you can ask your orchestrator admin in your organization, or if any senior folk who is there, or your solution architect, to give you an understanding of the workflow that you have designed, like how much consumption will be there, right? It's another performance metric. It will help you to build scalable and cost efficient solutions, right? And if you remember one sentence from today, let it be this: great architects don't optimize for the lower cost, they optimize for the better business value, right, with the most efficient architecture. So yeah, with that I end my session, and thank you. I'm happy to take your questions if you have any.
Yeah, yes, Ritabita. And I think it was a wonderful session, but there are some questions that needs your attention. So
Sure.
yeah, yeah.
Okay, let me go one by one. Yeah, so first question is platform units are consumed at design time, or it's only applicable post deployment? So yeah, I think I already answered this, that during the design time, platform units are actually consumed, but you have a evaluation tier for your user, so that is mostly covered in that. But if it exceeds, like, but I cannot tell you at this point like what kind of user you are on to, like you're a plus user or a pro user. So if you have, say for example, you have 1,000 units per day, right? If you have already consumed those 1,000 units, of course, during your design and eval time, if you have consumed those, then there will be a charge. But I mean, UiPath is, careful of giving, such allocations for all the users that they won't consume until unless you are rigorously using it or rigorously testing it, right? So most of the time it will be free for your design. Okay, and then I see. Can you show your pricing slide again? From Amruta. Okay, I think pricing slide. Okay, let's say that we don't have pricing slide over here. We have the platform unit consumption model slide. So, uh, as I told you in the beginning, that these are all publicly available information. You can actually go to licensing.uipath.com as well. You can find it there, or else after this session we can share with you the slides which you require. Okay, then the next question, Siley. I understand that UiPath has different units, allocation, development, production. After, apart from throttling between the request limits, are there any other differences or issues we should expect when running the same process in production? I'm trying to understand the performance impacts. Yeah, so this is a very good question. So let me summarize the question. So what Siley asked is like, if during my architecture choice, if I make a decision, will that actually impact my performance? Or like there might be some performance impacts, or there might be some failures and limitations that might come up. Yeah, I think Siley, that is applicable for everyone and for every design, right? Like if you are, like I said, that we have to save or make cost efficient solution. It does not mean we have to always have a lower cost solution, right? So if your solution is not capable of, or let's say you are using a standard model, or you are using a basic model, and your basic model is not capable of extracting data like a standard model, you have to go and use the standard model, right? Otherwise your solution will not be, uh, it will not be fulfilling the requirement, correct? So that is the reason you have to choose, you have to wisely choose. It's not like that, that because the cost will be lower, you need to choose a lower model. It actually has to solve the purpose, right? Whatever you are doing, you are solving the purpose, right? So that you have to see, and accordingly you have to make a choice, right? I hope I am able to answer your question. Okay, then Somadeep has, if we deploy our own ML model, then how we will compute it? Okay, so in that case, Somadeep, like I said, like there are options of bring your own model. So the consumption cost will remain the same. So how we will compute it is a different question. So you can actually see that whenever you are bringing your own machine learning model, and this was a feature of UiPath earlier as well. If you bring your own model, right, there will be still some cost. Earlier there was AI units, right? So there would be still AI units consumed. Now the same way the platform units are consumed. But if you are using UiPath models, probably there will be one platform unit consumed. But if you are using your own model, there maybe there would be zero point 0.5 platform unit consumed, right? That is the difference. Okay. Okay. All right. I think there were no more questions. So we can, yes, we can end the session. And thanks a lot again, everyone, for joining. Kunal, you would like to say something?
Yes. So first of all, great kudos to both you and Rashmi, because as a first-time speaker for the community, it was really wonderful. And specifically for me, like I haven't seen a session on this platform unit so far, and this has been a knowledge gap for me. And I think I've learned a lot from this entire session, because even when we speak about Maestro as well, like I've not seen. We always talk about exception handling within our RPA workflows, or we think of guardrails within our agents or something like that. But on a BPMN level, I haven't seen uh, all the use cases of exception handling and all the features that is available within the Maestro. So both the sessions, particularly for me, has been really a great learning session, and I think it has closed a lot of learning gaps for me. So really thank you to both of you for this wonderful session. I think just like me, many other developers and all the solution architects and analysts would have been benefited from both the sessions of this. So yep, thank you, and I also want to thank everyone who has joined this session. I hope all of you have scanned the QR for the community. You can also find that community link within the community.uipath.com for Kolkata. Please do join the community, because we keep coming up with wonderful sessions, and hope it will help all of you. And just a request to everyone who is here currently, like if you have any suggestions what the team should present, or the community as a whole should present to uh, all of you, right? If is there any topic that you would be interested to know or learn, feel free to reach out to us in LinkedIn. We are all available in LinkedIn, so anyone, it's not just me. You can reach out to Rashmi, Ritabrata, anyone. Somadeep is also here. We are all core part of the Kolkata community. So feel free to message anyone in the Kolkata community, and uh, like we can think about it and we can start presenting those sessions to you as well. And specifically, if you have more thing on Mastro and the licensing unit, we'll try to make it as a continuous session so that this learning gap keeps closing as much as possible. So yep, thank you to everyone who has joined, and thanks again to Ritabrata and Rashmi. I think if there is no more question, I think we will try to end the session today. It was a long session, so yep. So I'm just stopping the recording and we'll stop the session here for today.